Hi students, in this video we're going to be covering the rational root theorem. So, all right, a rational root is a root that can be expressed as a rational number, and every rational number is just one integer divided by another integer, and the denominator can't be zero. So if we have a polynomial of nth degree and we take it all the way down to a constant, if x equals c is a root of that function, two things are true. One, it means that f of c equals 0, which means that when we divide by the factor x minus c, we're going to get a remainder of 0. And x equals c is just a rational number that is of the form plus or minus p divided by q. P is the integer factors of the constant term, and q are the integer factors of the leading coefficient. An example would be if we had like f of x equals 3x to the fourth minus 5x squared plus x plus 2. So in this case, p is going to equal all of the factors of 2, which are just plus and minus 1 and 2. And q is going to equal all of the factors of 3, which is just plus and minus 1 and plus and minus 3. So all of the possible solutions are any combination of these numbers divided by each other. So you would have like plus or minus 1 divided by 1, plus or minus 1 divided by 3, and plus or minus 1 divided by 2, and plus or minus 1 divided by 3. Those are all of the possible rational roots for that function. And to determine if a rational root is a factor, we're going to use synthetic division. You should have done this in Algebra 2, so it should be a review, but we're going to go back over how we do synthetic division to get roots for polynomial functions. So first we need to determine all of the possible solutions for 5x to the fourth minus 2x cubed minus 3x squared minus 2x minus 3. So this value, -3, is our p value, and we'll just circle that entire thing, but q is going to be the 5. So p divided by q, so p over q, our set of possible solutions is going to be, well, we'll write that differently. Where's my eraser? All right, so we'll actually write this slightly differently. So all of the possible values of p are going to be, the factors of 3 are just 1 and 3. So we're going to have plus and minus 1 and plus and minus 3. And then for q, we're going to have plus and minus 1 and plus and minus 5. So our p divided by q list is, all right, so you're going to take the 1, and so we're going to have plus and minus 1 divided by 1. So plus and minus 1 divided by 1, we'll simplify later. And then we're going to have plus and minus 1 divided by 5. And then we're going to do the same thing with the 3. So plus and minus 3 divided by 1 and plus and minus 3 divided by 5. So all of our possible answers are here. And if we simplify this to be, so where we have our solutions without the plus and minus. So positive 1 divided by 1 is 1. Negative 1 divided by 1 is -1. Then we'll have 1/5 and negative 1/5. We'll have 3. We'll have -3. We'll have 3/5, and we'll have -3/5. And so those are all of the possible rational roots for this function. We avoid anything that would be redundant. So if we don't need to do, well, we'll see this on another example. So next we have a different function. We have 3x cubed plus 13x squared plus 5x minus 21. And we want to find all of the possible rational roots for this function. So our p is going to be 21. So we're going to have all of the factors of 21. So that's plus and minus 1, plus and minus 3, plus and minus 7, and plus and minus 21. And for q, we're going to have plus and minus 1 and plus and minus 3. And so then we're just going to take each value of P and divide that by each value of Q. We only need the plus and minus for the P value because that's already going to give us a positive and a negative. So first we're going to start with the 1. So we get plus and minus 1 divided by 1. Then we're going to have plus and minus 3 divided by 1. Well, you know what? So we'll just do each one divided by 1 first. Then we're going to have plus and minus 7 divided by 1 and plus and minus 21 divided by 1. So that's everything divided by 1, which is just a whole number. And then we're going to take each value and divide it by 3. So we're going to have plus and minus 1 divided by 3. Now, we don't need to do plus and minus 3 divided by 3 because that's going to give us the 1 term. So that's redundant. We can skip that. And so then we need to do plus and minus 7 divided by 3. And we don't need to do plus and minus 21 divided by 3 because that's just positive and negative 7. So all of our possible solutions are 1, negative 1, 3, negative 3, 7, negative 7, 21, negative 21, 1/3, negative 1/3, and positive 7/3 and negative 7/3. So those are all of our possible solutions. So you take these solutions and you do synthetic division to reduce this down to a quadratic function. And remember, all quadratic functions can be solved via factoring or the quadratic formula. So synthetic division is useful in reducing that equation. So when you do synthetic division, you're always doing it with one of the possible rational roots. And again, you should reduce the equation down to either a cubic that can be factored via grouping. We'll see that in a new section, or do synthetic division twice to get that down to a quadratic. So each time you do synthetic division, you reduce the degree of the polynomial function by 1. What that means is that if we started with like a 4th degree polynomial, if you do synthetic division once, then the result is a 3rd degree polynomial. And if you did synthetic division again, you would get a 2nd degree polynomial. It's a very straightforward process. We'll see on the next slide. So we need to use synthetic division to find all of the roots for 2x cubed minus 11x squared plus 13x minus 4. So first, let's do our P over Q list. We know P is going to equal the factors of 4. So that's plus and minus 1, 2, and 4. And for Q, the factors of 2 are going to be plus and minus 1 and plus and minus 2. And so our P over Q list, we're going to have 1 over 1. So we're going to have negative 1, positive 1. Then 2 divided by 1 is going to give us 2. Then we'll get negative 2. Then we'll have 4. And we'll have negative 4. And then 2 over 1. We already did 2 over 1. I'm sorry. So then if we do 1 over 2, so we're going to get, why did I do that? Need a half. I gotta get the eraser. So we want to make that was 4 and negative 4. And so then we'll have a half and negative 1/2. 2 divided by 2 is going to be redundant, and 4 divided by 2 is also going to be redundant. So all of our possible rational roots are here. And so from here is just guess and check. So I would always recommend starting with 1 or negative 1. So the way synthetic division goes is you pick a number. So you pick one of these numbers, say we select positive 1. So we're going to put 1 right here and excuse me. So then we write all of the coefficients of the function, and there's going to be a 2, a negative 11, positive 13, and a negative 4. And the first value we bring all the way down. We're going to bring down a 2. And so then you take this 1, you multiply it by 2. So we're going to do 1 times 2 is 2. You add those values. So negative 11 plus 2 is negative 9. And so then 1 times negative 9 is negative 9. 13 minus 9 is 4. 1 times 4 is 4. and negative 4 plus 4 is 0. So this last value is the remainder. And so since that's our remainder, we started with this was 2x cubed, this was negative 11x squared, this was 13x, and this is the constant. So when we do synthetic division, everything goes down by a degree of 1. So that's going to be 2x squared minus 9x and plus 4. And so now we know, since we got a remainder of 0, one of our roots is x equals 1. And so now we have this other function. We'll call this f1 of x, just so it's different from the original function. And so that's 2x squared minus 9x plus 4. And so now you have to find the solutions to that, and that can be solved easily by factoring this to be, all right, so we need factors of 8 that give us negative 9. So that's going to be 2x squared minus 8x minus x plus 4. And then you factor out a 2x. So we'll get 2x times x minus 4. You factor out a negative 1, you'll get another x minus 4. And so that factors to be 2x minus 1 and x minus 4. And so our other two solutions are x equals 1/2 and x equals 4. So it's entirely possible that when you do synthetic division, you get a remainder that is not 0. What that means is that that number you chose is not a factor. So you just have to go back and do the process again until you get 0. So again, I always recommend starting with 1 and negative 1 and then just moving up from there. But this is how we do synthetic division. So we found our three solutions. They are 1, 1/2, and positive 4. So we're going to do synthetic division again to find the possible roots for 6x to the 4th minus 19x cubed. You can read the rest. So our p is the value of 9. So p is going to equal all of the factors of 9, which are plus and minus. And then in a set, we're going to have 1, 3, and 9. And then the factors of q are going to be plus and minus. Let's see, you get 1, 2, 3, and 6. So let's see. So our p over q list is going to equal, right, again, all of the values. So first, we're going to get just all of the whole numbers because we're going to divide by 1. So we'll get plus and minus 1, 3, and 9. And then we take all of the values and divide by 2. So we'll get plus and minus 1/2, plus and minus 3/2, and plus and minus 9/2. And then we'll take all the values and divide by 3. That'll get us a 1/3. 3 divided by 3 is going to be 1, and 9 divided by 3 is going to be 3. So we don't need to do that one. And then we're going to take all our values and divide by 6. So we'll get 1/6. 3/6 is going to be 1/2, and 9 over 6 is going to be 3/2. So we are done when we get to these 1, 2, 3, 4, 5, 6, 7, 8. So really there are 16 possible solutions if you count the positives and the negatives. Again, I recommend starting with 1. So let's see what happens. We're going to take our 1, then we're going to put 6, negative 19, negative 7, 27, and positive 9. If there were any missing powers, you would put in 0, but since they're not, we just write all of the coefficients. So remember, you bring down the first term. So then 1 times 6 is 6. Negative 19 plus 6 is negative 13. 1 times negative 13 is negative 13. Negative 7 plus negative 13 is negative 20. 1 times negative 20 is negative 20. 27 minus 20 is 7. 1 times 7 is 7. 9 plus 7 is 16. So 16 does not, 1 does not work. So that means that we need to choose a different value for synthetic division. So next, maybe we try -1. Now, I haven't worked this ahead of time. Well, I did, but I forgot the actual solution. So now we're going to try -1. We still bring down our 6. -1 times 6, -6. -19 plus -6, -25. -1 times -25 is +25. -7 plus 25 is 18. -1 times 18 is -18. 27 minus 18 is 9. -1 times 9 is -9. And 9 minus 9 is 0. So that factors. So next so now we know that x equals -1 is a solution. So from there, we're going to reduce our function to be 6x. So let's see where we can write this. We'll write this up here. We get 6x cubed minus 25x squared plus 18x plus 9. So we get a different cubic function. But if we do our P over Q list, we're actually going to end up with the same values. So now we need to do synthetic division with, I don't know, let's try 1 again. And so we'll get 6, -25, +18, +9. If we bring down 6 again, we're going to get 1 times 6 is 6, and that's going to be -19. -19. -19 is going to give us -1. It's going to give us -1 and 8. So 1 doesn't work. We already tried. So it's possible that -1 could be a root of multiplicity of 2. But I think when I made this example, I did not actually use that. So instead, we're going to move on to trying maybe a fraction. So let's try like a half, for instance. And so you can see that rational numbers also work here. So say we try 1/2 doing synthetic division. We'll bring down our 6. 1/2 times 6 is 3. -25 plus 3 is -22. Half of -22 is -11. 18 minus 11 is 7. And 1/2 times 7 is, we'll say like 3.5. And when you add those, you don't get 0. So 1/2 doesn't work. Next, we'll try -1/2. So we'll take that out. And now if we bring down the 6, -1/2 times 6 is -3. That's going to be -28. -1/2 times -28 is 14. 18 plus 14 is 32. -1/2 times 32 is -16. That adds to be -7. You do not get 0 as a remainder. So -1/2 doesn't work. So we try both of the halves. And that means we need to move ahead to some other value. Let's try 3 halves instead. So we bring down 6. 3 halves times 6 is 18 divided by 2, which is 9. -25 plus 9 is -16. 3 halves times -16 is -24. 18 minus 24 is -6. And 3 halves times -6 is actually -9. So we get a remainder of 0. So now we know that x equals 3 halves is the solution. And now we have this equation that is 6x squared minus 16x minus 6. We'll call that f2 of x. And so now anytime you get down to a quadratic, you can solve that one via factoring or the quadratic formula. So we had -1 and 3 halves. I'm not sure why I erased that. So it was x equals -1 and x equals 3/2. So now we have this equation 6x squared minus 16x minus 6 equals 0. First thing you can do is take out a 2. So that will give us 3x squared minus 8x minus 3 equals 0. So we're looking for factors of -9 that add to be 8. Let's make that 3x squared minus 9x plus x minus 3 equals 0. You can factor 3x out of the first term, so you get 3x times x minus 3. Then you can factor out a 1, and that equals 0. So you factor out x minus 3, so you get 3x plus 1 times x minus 3 equals 0. So your other two solutions are x equals 3 and x equals -1/3. And those are the 4 solutions to that polynomial. And that's how we use synthetic division to get our roots. I will tell you on a test, I will give you 1 or 2 solutions so that you don't have to fool around doing this, what could be a lengthy process. All right, so that's going to conclude our video on synthetic division to find roots for an equation. Next video we're going to cover is factoring.